So this last part is amazing because it connects to something that we did in the beginning of the year, or that you did last year when I wasn't here. So I said, wait a minute. If I can turn like e to the x and cosine and sine into a polynomial, can I turn a polynomial into a polynomial using the maclaurin series? So I said, well, what's going on with x plus 2 to the third power? So I said, well, I should be able to apply the same rules, right? So I was like, fine. Once again, this is f of 0 plus f prime of 0 over 1 factorial x plus x double over 0 2 factorial x squared plus f triple over 3 factorial x cubed plus, x quadruple to the 0x to the fourth over 4 factorial. And it turns out I don't need 4 terms. I need 3 terms. So I need to the x to the third because I know binomial expansion, or I know this is going to cut off. Let's explore that for a second. So, fine. If this is f of x, then f of 0 is, let's see, 2 to the third, or 8. So f prime of x is equal to 3x plus 2 squared. So f single prime of 0 is equal to 4 squared, or 12. I know f double prime of x is equal to 6x plus 2 to the first. So f double prime of 0 is equal to 12 also. And then I can take the triple. F prime of x is equal to 0. No, sorry. That's going to be 6. So f triple prime of 0 is 6, and then f, and so on, that's 0. So I can write this as 8 plus 12x plus 12x squared over 2 factorial, right, plus 6x cubed over 3 factorial, and I get 8 plus 12x plus 6x squared plus x cubed. And I was like, wait a minute, that is what it is, right? So x plus 2 times x plus 2 equals x squared plus 4x plus 4. And then if I multiply this by x plus 2, I get x cubed plus 4x squared plus 4x plus 2x squared plus 8x plus 8. Final answer, x cubed plus 6x squared plus 12x plus 8. And then I say to myself, if I can do that with positive exponents, there's absolutely no reason why I can't do it with negative exponents and fractional exponents. How about x plus 3 to the negative 2 power? Let's see. Well, if the rules don't change, what's f of 0? F of 0 is 1/9, right? What's the first derivative of x? Negative 2x plus 3 to the negative 3. Therefore, what is f prime of 0? Well, that's negative 2, 1 over 27. What's the second derivative of 0? Let's see, we have 6x plus 3 to the negative 4th. That's f of x. So what is f double of 0? Well, that's 6 over 81. And we can take it as, we can actually expand this out infinitely. Let's go to the next term. What's the third derivative of x? Well, that's negative 24 over x plus 3 to the 5th. So what's f triple 0? Well, that's negative 24 divided by 243. And we're done. And so that means that instead of memorizing that weird formula, as long as you know how to do a maclaurin series, you can now say that x plus 3 is equal to 1/9 plus negative 2 over 27 divided by, it's negative 2 over 27x, right, plus 6 over 81 divided by 2 factorial x squared, plus, let's do the last term, negative 24 over 243 divided by 3 factorial x cubed. And now we've just expanded out this into the x to the third term. Let's make it nice and pretty. We have 1/9 minus 2x over 27 plus, what do we have? 6 divided, so it's 3 over 81 or 1 over 27 x squared, right? And then what's going on over here? We have minus 4 over 243 x to the third. And what we've just done is all that work from chapter 1, expanding out a binomial to a negative power. We could even take it further. Okay, so I made a mistake at the end, so I have to read you this part. Let's take a look at, so we can therefore expand using maclaurin series, we can expand any binomial to any power. So I can make up, 3x minus, let's keep it a little simple. So let's do 3x plus 1 to the negative, half, or negative, 2/3. Yeah, 3x plus 1 to the negative 2/3. So we have, this is a function, and we want to write this thing as a polynomial. So, first of all, I need f of 0. Well, f of 0 is 0, that's just 1. So, f prime of x is equal to negative 2/3 times 3x plus 1 to the negative 5/3 times 3, which is simply negative 2. Yeah, negative 2 times 3x plus 1 to the negative 5/3. Well, if x is 0, so if f prime of 0 is equal to, this is 1, this is just negative 2. Right? And then let's do another one. The second derivative of x, right? Let's take this. So we have 10 over 3 times 3x plus 1 to the negative 8/3 times 3. Remember, we take the derivative of the inside chain rule. Well, this goes out, and then the second derivative at 0 is equal to, this is 1, this is just 10. And then let's do the third derivative of x, which is equal to, let's see, negative 80 over 3 times 3x plus 1 to the negative 11 over 3 times 3. So these go out. This part is just 1. So the third derivative at 0 is negative 80. And then last but not least, let's do the fourth derivative. Well, they generally don't ask for the fourth derivative, and therefore we're done. So this is equal to, so the binomial 3x plus 1 to the negative 2/3. This isn't anything that asks because it seems confusing, but it ends up being really not. Once again, at 1 plus the first derivative over 1 factorial x plus, and we'll fix up the negatives to make it look nice and pretty. What do we have for the second derivative? We have 10 over 2 factorial x squared, and then what's the third thing? We have plus negative 80 over 3 factorial x cubed, and let's fix this up. We have 1 minus 2x plus 5x squared minus, well, what do we have? The 80 to, let's see, 80 over 6, 40 over 3. Okay, so it's 40 over 3x cubed. And this is the expansion from chapter 1 of 3x plus 1 raised to the negative 2/3 power using maclaurin series. Sounds good.